Good evening, everyone. How are we all doing? Just get the chat on. Right. If you could let me know if the audio is okay, or anything. Just I can see someone's messaged in me, awkward Yoshi, whoever that is. Excellent. So, how I thought this would work is you can ask me messages in the chat. If that doesn't work, you can always drop me a message, I guess. But yeah, so the plan is I can go through some questions. I have Word all ready to play, actually, because I haven't done it today. So while you're thinking of your questions, let's get into Wordle, shall we? Let me hide the chat so I don't want anyone spoiling this. So, sorry, here we go. So, right, I'm sure we all know Wordle. We've got 5-letter words and we need to figure out what it is. I'm going to try and aim to do it within 3 or 4, but we'll see. So I think a good word to start with, actually, is normally something that contains spells or like combinations of stuff. Definitely not my pronunciations. So while you're doing this, there we go. Let's take that way down and bring the mic up a bit. Hello, hello, hello. There we go. Is that better, Imogen? Yeah, is that turned down now? It should be almost non-existent. It's hopefully non-existent. Perfect. Okay, so what we're going to go for here, and I might need your help actually with this, so we'll see. So I think a nice word to start with, let's go for agile. Oh, okay. So, slash anything slash I'm gonna go for slash. What is it? Flash? I mean, okay. I mean, yes. So that was a good start. So any questions yet whilst I'm messing about with this? We've got GeoGuessr next. Any questions? Flash? Before I move on to GeoGuessr, any questions that I can ask about statistics, about writing, about anything about the assessment? Oh, Marlo, come on. We might have a little person to join us as well. Good. And here she is. I might have mentioned her a little bit. You can say hello, Marlo. You say hello? Say hello. Don't just smile. Hello, not lab report related, sorry, but that's fine. Wordle's not lab report related either. I've completed half of my RPT and ran out of citizen set. Oh, good. Good question, Gabriella. Well done for that as well. So the RPT, I did mention it as an announcement, but just to clarify, I'll send another one. Obviously... Uh, just to mention with the RPT, so you don't need to get that until the end of week 12 in second semester now. So what we realised was, I'm sure you found out, that
I do that.
most of the studies to do RPT go on in January onwards because they're part of the dissertation module. So that's why we've kind of looked at it and thought, you're all going to be kind of scrambling for the same studies on Sona. So what's happened is it's going to become part of your qualitative grade. So you'll get an RP. Oh, there's another person here. Come on, Kit. Come and say hello. Kit, come here. Don't knock anything. If you knock anything, then big trouble. Come and say hello to everyone. This is Kit. Jacob, are you there as well? Yeah, come on, Jacob, because everyone wants to see the little one, my little ones. Kit, Jacob, come here, please. Just come and say hello to everyone. The world is watching. Jacob, well, by the world, I mean 44 people. I mean, got a long way to go, but there we go. Kit, have you got a message? Jacob, don't knock that, please. Kit, have you got a message for everyone? What are you doing? Kit, have you got a message?
No.
They're doing statistics, which is like maths.
That was what my flow was.
What was? And here's my oldest one. See, this is the family roads. Kit, Jacob, can you say hello?
Hello.
Can you ask the audience a question? No?
I will.
No. Marla, can you ask a question? Don't knock this, please. Could you go around that way? Don't knock it. What's your question?
I like Daddy and I love Daddy and I love Kit and I love Jacob and I love Daddy and I love Poopy.
No, we're not mentioning Poopy. Right, out, go. Kit, if that falls over, you're in big trouble. Get off there, please. Go. Jacob, could you go, please?
And I like Daddy and I love Mummy with...
This is why I don't work from home. Right, Kit, could you go, please? Because I need to concentrate because I'm answering questions.
I love Mummy and I love Daddy and I...
Right, that's the call. Go on. Right, Daddy's doing work. Well, work. Right, thank you. Thank you for coming to see me. Thank you. Kit, don't knock that. Right, Jacob, could you go as well, please? No, you're not staying. Could you go? Anyway, sorry. Right, so what have we got? So hopefully that answers the RPT question. Next one. What graphs should we show for multiple regression? The only plots in Jasper are residual ones. Exactly. So the only one that I've suggested is... You're not playing YouTube Kids. The only one that you could put in, but you might actually put it in your appendix, use a JX4, NN4. That you might want to put it in just as evidence of those assumptions, right? The residuals versus predicted graph. The only other one that you might put in, especially if you've got anything like a significant predictor, is the correlation matrix. So you might want to put in a you might want to put in the correlation matrix, which shows the scatter plot for each of the predictors and the outcome variable. Yeah, she's coming. Come on, Marlo. Thanks, Marlo. Thanks for helping. So you might want to put that in. There's no real, like an ANOVA or a t-test, there's no real kind of like bar chart or line figure or anything for regression. So that's what actually is the visualization, I guess, of that data is the coefficients table that you might want to put in or write in text. Hello. 3 questions. Okay, Emily. Do we need to say that we use JASP to analyze? Yes, you can mention that in your analysis, but don't spend too much. Just literally say we use the statistical software JASP to analyze the data. You don't have to say anything more than that. Where should you put that? I just build it into your the start of your results section. Okay. When reporting out normality checks, Shapiro-Wilk is the test for if your data is normally distributed. She nicked my phone. No, she hasn't. when reporting our normality checks, are we looking at the result next to Shapiro-Wilk or this all the p-value? Yeah, exactly, Emily. So the p-value of the Shapiro-Wilk test, that tells you whether whether you have a significant. If it's significant, that says that the assumption of normality has been violated. If it's significant, so the significance is bad. Well, not bad, but it just means that it's been violated. Is it okay to report the descriptive statistics for the predictor variables and the outcome variables in separate tables? Would you prefer all of this? Yeah, descriptives have all in the same. Sorry, have all the predictors and the outcome variable in the same table. That's fine. Thank you, thank you, thank you. We accidentally left 2 outliers in the report. Is that fine? And I just report it. Yeah, that's fine. Again, the thing with open science and like the pre-registration and stuff is just being like honest about it. So if you mention that in your report and you feel like you've analysed your data and you can't go back and redo it, which I guess sounds horrendous, is just being honest that that you had outliers. Now there are 2 train of thoughts here. So the first is actually, I've always been taught to keep outliers in unless they're like ridiculous. I'm going to load JASP up for that reason, actually, a few of the questions. Let me just do that whilst I'm going to answer this. JASP, where are you? It's bedtime, that's why there's chaos. Where are we? Right, I need to get a new version of JASP. Let me just quickly, if you don't mind, let me just grab this here. And let me just JASP stats. I just need to get the latest version so I know that I can show you the best. That's okay? Is this Apple Silicon or Apple Intel? 1 second. We are on Intel. Right, 1 second, and I'll have some data for you to show you. So, right. Whilst that is downloading, come back here. Let's come back here. Right, where was I? What was I even saying? Yeah, so 2 train of thoughts. So with outliers, right, I was always taught to keep them in because I always got enough data points. So the idea is, imagine this, right, just a little thought experiment. Imagine if you had 100 participants in your study, yeah? And you had 1 outlier. Would it be worrying if when you remove that outlier and analysed your data again that the result completely changed? Yeah? I would argue yes. Oh, God, she's back. Right, hello, are you coming to kiss me goodnight? Yeah? Right, see you in a bit. That would be bad, right, because 1 data point in 100 is 1%. So just by removing 1% of your data, it changes everything. That would be bad. However, imagine if you had 10 participants and you removed 1 outlier. Now that becomes 10% of your data, and that would be much more of a problem, but much more likely that it would change your result. Yeah. So if you've got a fair amount of participants, I'd say north of 30 or 40, if you have 1 or 2 outliers, it shouldn't change the outcome of your result. Okay. Hope that makes sense. George, right. For some reason, we didn't include the gender of our participants. Is this going to be a problem when no, you don't have to record the gender or biological sex of the participants. I mean, I guess it's only if you're really super interested in reporting the demographics. If it's not important, then, we don't record the height of participants. Yeah? How do you do box plots? You don't do box plots in multiple regression. Multiple regression, to do the box plots, you need to... let me just drag this over here. this here. Sorry, I'm just installing this whilst I have a chance. Sorry, I didn't realise I needed the latest version on here. Desktop, JASP. There we go. Install, please. Install, please. Right. There we go. JASP, JASP. Right, here we go. What was I saying to you, George? Yeah. Oh, sorry, Imogen. You don't do them in... Yeah, they're a little bit hidden. They're in the descriptive section, but I'm just about to open this and show you, yeah, how to do it. 1 second. Oh, it's just copying over. Yeah, I'll show you. I'll literally show you in a second. Let me just get a data set to play with for JASP. Let's do this one. Where is this? Showing Finder. There we go. PSI JASP. Stats for JASP. Don't even know what this study is. I'm just going to open it in JASP. Where is it located? It is in expectation model. Right. Sorry about this. I should have. Ah, there we go. Let's show you. Let me drag this across here. Please ask away as well with all these questions. It's really good that you're answering them. So thank you for that. I'll stop in a second and do GeoGuessr just to see, just to break stuff up. I know it's Friday evening, so I don't think my partner's best pleased with me for doing this on Friday night with 3 children, but that's fine. This is what I do for you. I'm hoping you didn't hear that as well. Right, here we go. Finally, let's get this. Data library. Let's have a look at regression. Album sales. Right. Did you know you could do that, by the way? There's a whole folder of data that you can use, which is quite useful, I think. So, Imogen, if you wanted to get the box plots, you come to descriptive statistics, and for those variables that you want to get box plots for, you whack them into here. You come down to customizable plots and click on box plots. Here, and here we go. These are the box plots. Kit, what are you doing back here? Oh my god. This is the maths one, by the way, aren't you, Kit? What's 7 times 6?
7.
Don't let me down. It's only 5. 7 times 6. Don't crash and burn.
42.
Excellent. Right. Does that answer that question about box plots, Imogen? Oh, Emily's got a 4th question. Emily, you're getting in your usage here. If the normality check has been violated, how do we report this in the lab report, and do we have to do anything following this? Yeah, so this is a good question. This is also in relation to the Levine's test, or if Levine's test, which is homogeneity of variance, is significant. We haven't had the time to teach you something called non-parametric tests, and they're actually in JASP here.
Yeah.
He's coming down now. Are they actually even in here? I don't think they are. No, they're not. They're not even in here, so you couldn't even do it in JASP anyway. Okay, you've got to go now. Say good night. Say goodbye to everyone.
Goodbye forever.
Right. See you later. Love you. Bye-bye.
Bye.
Bye. Yeah. So sorry, what was I even answering? Emily again, wasn't it? Yeah, so in the real world, if you have a normality violation, you're not strictly supposed to do ANOVA. One half of the field would argue that actually ANOVA can deal with small deviations to the assumptions. Another half of the field are like, no, you shouldn't do it. simply don't have the time at the moment to like also teach you a whole new world of statistics, which is called Bayesian statistics, as well as another branch which are called non-parametric statistics as well. So all I want you to do is be honest and acknowledge that normality was violated and report the p-value. That's all you need. That's as far as you need to go, Emily. That's okay. Is the survey added to the lab report? You could put it. There's no harm in putting it in the appendix. You don't have to. What I would say is just make sure that you cite the survey, you know, where it was published originally and stuff like that in your method section. The cheat sheets that's shown in one of the weeks on the KLE, is that all we need to add in the results section? Yeah, pretty much. I mean, let me. I could show you. Is it worth me running through? Do you want me to go through just doing a regression and all the stuff that you need here? Is that useful? Do you want me to do that? I'm guessing you're going to say yes, so I'm just going to do it. So let me just make this a bit wider. Right. So with regression, let's just grab this, not mixed models, linear regression. Right. So with regression, oh my God, can you hear this? I like to think of it as like a two-stage process. Love a bit of Bayesian, less please. Okay. I think we did or brushed over them. Yeah, exactly, with the non-parametric. So I'd rather do it properly. So maybe you come across that in third year with non-parametric or Bayesian. Who loves Bayesian? Yeah, I'll do the ANOVA as well. Yeah. I know exactly who asked that as well. So yeah, I will do that as well. So regression. So let's just what are these variables? So we've got adverts, whatever that means, sales, airplay, and attract. Let's have a look. Does it say what the variables are up here? Okay, I thought it did, but anyway. Let's just say we want to have a look at a simple model which looks at predicting sales from whatever these other three variables are, right? I guess that's the amount of adverts, the airplay, how many hours on a radio station, and some attract metric. I don't even know what that is. Yeah, that sounds sensible, doesn't it? Predicting sales from these three. Right, so what do we need? So let's just go through. So, I mean, we've got stuff already, right? But let's just, I like to go through and make sure we've checked everything. So what do we need? We need none of this. It's always nice to have the tolerance and VIF. I'll explain what they mean in a second. Model spec, we don't really need to change anything here. There's not really that much you have to need to click on really for... Oh, you can get the descriptives as well here. As well, you don't have to go to the descriptives tab, so you get those there as well. And for the assumption check, this residuals versus predicted. Okay, so what does all of this mean? Let's start with the model, and then we'll look at the let's do it this way. Let's look at the descriptives first, and then go through what we need to report. So. With the descriptives, actually, I mean, you can report the box plots or the histograms for each of the variables that we've looked at. I mean, I haven't put all of them in there with the descriptives tab. Hang on, let me scroll up. Let's put that in there as well. So so you should report these, and you can report them as a table. I would personally, to save words. But they're not actually that diagnostic for regression. But they're interesting to know. So I would put stuff like the box plots for these in the appendix. And you might put that descriptive table into... And don't forget, you can just click on here, copy and paste it into Word. It's APA formatted. So the descriptives, fine. You can also get the descriptives here as well. They should map on. I was like, oh. So you can put this table in. That's a little bit more condensed, this table, so you might want to put that in. And then we move on to the why is that doing that? The assumptions of the regression. Now, there's two main assumptions really. The rest are from the design, but the ones that you can get from JASP, I'll just talk through now. So the first one is this idea or the concept or the property of multicollinearity. Okay, now multicollinearity is whether the predictor variables, so in our case, what were they in our model? I forget already. The predictor variables were advert, airplay and attract. Whether those are too strongly correlated with each other. Okay, above, as a rule of thumb, 0.8. Yeah, now to get that, we come over to regression here, click on correlation, I'd put all of your, and I'll tell you why, I'll include sales here as well. And this gives us this correlation matrix. Okay, it's telling us that, so we're looking at the R values here, so Pearson's R, and whether it's significant. We don't actually really care so much whether it's significant or not. I've asked just to flag the significant correlations, but we're just looking to see if any of these pairwise correlations are above point or above negative or plus 0.8. So very, very highly positively correlated or negatively correlated. They're not. So that's one way you can check multicollinearity. You just, one simple sentence in your report saying, I think I've done this in the examples, but you could say the multicollinearity was, that assumption was not a problem because all pairwise correlations amongst the predictors was less than 0.8. Yeah, just one sentence. Another way we can check it is actually, remember when I mentioned this VIF thing, VIF, this stands for variance inflation factor. And the rule of thumb here is that any of those numbers there, of these predictors, advert, airplay and attract, if this VIF number is below 10, that means multicollinearity is also not a problem. So there's two ways of checking. You could write about one, you could write about the other one, which was the correlations being greater than 0.8. Or you could just quickly mention both. But that's up to you. So that's the assumption of multicollinearity. The second assumption you get by the visual inspection of this plot here. Again, how we got that plot was, come to linear regression and come down to plots and click on residuals versus predicted. Okay, that gives you this plot. Now what this plot is imagine for the model the line of best fit. Okay, now the line of best fit is not really a line. We're looking at a line here, but because we've got three predictors, it's actually a 4-dimensional space. We have our 3 predictors, so that's 3 dimensions, and a 4th dimension, which is the outcome variable. Let's just say we put a line of best fit, i.e. how does the model best predict sales from the 3 predictor variables? And that's what JASP gives us here, right? Now a line of best fit is normally, I don't even know how to do this, right? Like this way or this way, yeah? Now imagine we've took that line of best fit and we've just rotated it to be horizontal, okay? That's what this red line is across here. Now if you remember from the theory lectures on this, a residual is the difference between the model, which is the red line here, and the actual data points, which are represented by each of the dots here. What we want for the property or the assumption of homoscedasticity is that when you look above and below the line, you have a roughly equal dispersion of those dots, those residuals up and above and below the line. As you move across from, the green screen's to here, from left to right. So as you move along the x-axis, are the distribution of those dots here sort of roughly the same across there? And they are here. So you just say a visual inspection of the residuals versus predicted data points. See figure 2 or whatever, see figure 1. A visual inspection showed that the data had the property of homoscedasticity. That's all you need to write. Okay. Again, this isn't like a result. This is more part of the diagnostics of the assumptions. I would put this personally. You won't get like marked down for putting in your results. I just think it might break up the section a bit. I would put this in your appendix, but just refer to it when you put that sentence in about homoscedasticity. Just pop it in there. Okay. I'm just going to check the chat that I haven't like gone on a bit. Do we put not all of the graphs, Molly? I'd put the key ones that you want. So I'll go through an over in a second, but for an over, you want kind of the interaction plot, which I'll show you. And that's the main one. For regression, as we discussed earlier, there's not really a graph of regression. It's more to do with the coefficients. But you could put the correlation matrix in. But let's just keep it. So we've done the assumptions, yeah? Multicollinearity, homoscedasticity. Now we move on to the analysis itself. So what you want to include, it's a 2-part analysis. So the first thing is, does the overall model work? Okay? That's including those 3 predictors and that outcome variable. Does that equation work? Does it predict album sales from those 3 predictors? And the number that we're looking for that is R squared here. Yeah? Which is 66.5% or 0.665 as a proportion. Now, that number is a little bit like an F value, a T value, an R value for a correlation, right? It's a number. It says, hey, there's a strong proportion of variance accounted for here. What I'm hoping you're asking yourselves is, but is it significant or not? And we get that from the ANOVA box here. Okay? Now, it is significant. Yeah? So when you come to the first part of your reporting your regression, after you've talked about the descriptives and the assumptions, is that that you say overall is the model significant. Yeah? Now, if the model was not significant, that would mean generally that this R squared number would be like 0.01 or something, really small. That's where you stop. Yeah? It's a bit like ANOVA. When you do look at an ANOVA, if the main effect or the interaction is not significant, you stop. You don't carry on. Yeah? But this is here. So you'd say the overall the model was significant. R squared equals 0.665, which was statistically significant. P less than 0.001. Yeah? It's significant. So that means now we go on to our second stage of the regression analysis, which is, okay, it's a bit like ANOVA, and I'll let you think why, but the question now becomes, which of those predictors is significant? It could be that all of the predictors are significant. It could be that just one of the predictors is significant and really driving the effect. It could be that 2 are. We just don't know. So what we look at here is we come to the coefficients table, and again, you copy and paste this coefficients table into Word, which is what I would do. So you don't have to write out all of these betas and stuff. What we're looking for is the p-value column here for adverts, airplay, and attract. These 3 p-values. And as you can see, they're all statistically significant. So each of those predictors has an impact on album sales. So adverts has an impact on album sales. Airplay has an impact on album sales. And whatever that attract variable was can predict album sales. Here's where the visualization comes in. Okay? Now, if you remember, we looked at correlations, yeah? correlations. Now what we can do, if you come down here, you can do scatter plots. Now it's not strictly the same as the betas, but the betas kind of correlate with the R value. So a positive beta, which is this column here, the unstandardized column, this is the slope, whether it's really steep or really flat. So a slope of 0 would be a flat line of best fit. A negative slope would be like this way, and a positive slope would be like this way. So these values here are positive, so they map on to like as a positive correlation. So there's a positive correlation between attract, because this is a positive number, and album sales. There's a positive correlation between airplay, so the more airplay you have, the more album sales that you have. And here we have a smaller number, 0.085, quite a small number, but that's suggesting that the more adverts that you have, the more album sales that you have. This kind of makes sense, yeah? Now we can see this in this correlation matrix. So the correlation matrix here is this data in the table, but this is the scatter plot for each of those correlations. So let's read. So how we would read this is for the adverts variable predictor. How does that relate? If you remember, sales was our outcome variable. So can you see how adverts has this real clear relationship, this line of best fit? As you increase the adverts, sales goes up. What else does sales? Let's have a look at sales as well, with sales and airplay. So as you increase airplay, so does album sales increases. As you increase attract, whatever that was, as you go up in attract, you also go up in terms of album sales. So you can use these scatter plots here, these the correlations between each variable. You can copy and paste this in. You can save it as an image, or you can copy it and paste it into your Word doc. This just gives a visual representation of how those coefficients or the predictor variables relate to the outcome variable. Okay? Does that bit make sense? Oh, it's Abby as well. Oh my gosh. Abby's a master student who's probably in here to cause chaos. Does that make sense so far? Have I said anything like ridiculous? I know I say a lot of ridiculous things, but are we okay so far? Please like and subscribe. I've always wanted to say that. Are we okay? Because there's not lots of comments like being negative, I'm assuming we're okay so far. Okay? Now there's one final thing in the analysis. If all of our predictors are significant, like we have here, the question becomes, what's the strongest predictor? Yeah? Now, what you could posit is that you look at the betas. If you remember, the unstandardized column is the slopes, and you say, well, actually, the bigger the number here, the steeper the slope. Don't forget the notification button, yeah. Yeah, I didn't have time to put that on. So you could argue that the biggest unstandardized number here means a bigger slope, which means it's a stronger predictor. That's a good theory, but it's actually wrong. Okay? Why? All of these measures, adverts, airplay, and attract, are on different scales. Yeah, they're different measurements. It's like, for example, having one predictor that is in milliseconds and another predictor that's in kilometers. Yeah? They're not on the same scale. So looking at the raw, unstandardized coefficients, it can tell you something about the strength, but it doesn't really. It's just down to the unit of measurement. What we really should look at is this column here, the standardized column. Okay? So this standardized column tells us the bigger the number, the stronger the predictor. So looking at the unstandardized, we'd think, hey, the attract variable is the strongest predictor, but it's not. It's actually the weakest. The two strong, I mean, these are inseparable here, 0.511 and 0.512. It means that adverts and airplay are the strongest predictors of album sales. But attract still has some impact. But this is what you'd write in your discussion, right? You'd say like, look, these are all significant. However, it's really airplay and adverts which are the real strongest ones. Yeah, Candice, oh my gosh, are we in the first half? We started a little bit late, Candice, but it should be recorded on YouTube. So I'll put the link in the on the KLE. I'm also hoping that this is fine with Keel. We'll soon find out. So that's it for the analysis. Yeah, that's it for regression. That's all we need to. That's all we need to put. Awkward Yoshi. Yeah, it makes sense. Stats to me just goes in one ear and I kind of get the 5 pound. That sounds like me on a daily basis. You're so real for that. I don't know what that means, but I'm happy to be real. Okay? Okay. Yes, I will now move on to ANOVA. Okay, so let's grab another data set. Open data library, ANOVA. What have we have here? 3x3 mixed design, repeated measures, factorial, erotic pictures and love. I'll steer clear of that one. Facebook friends. These are all from Andy. Okay, attitudes towards. Right, let's grab this one. My good friend Andy Field has done this. So let's have a look. What have we got here? Right. Okay, let's have a look at the data first. Okay, what is this study? So this data set, alcohol attitudes, provides attitudes towards water, wine and beer. So one factor with 3 levels. After watching positive, neutral and negative imagery of that drink. So it's repeated measures because all of the participants experience all of the conditions. Yeah? Okay. Right, I want to get rid of the analysis and want to do it from the start. So let's get rid of let's put all this back. Cheerio. So, there we go. Get rid of everything. I just want to get rid of everything. Get rid of everything. Get rid of everything. Contrasts we don't need. Simple. Oh no, we don't want simple main effects. We haven't talked about the beauty of simple main effects. Let me just get rid of this. Boop, boop, boop. Right. Post hoc tests. Let's get rid of those as well. Boop. Right. So when we're doing a repeated measures ANOVA, we have, as you can see here, we have columns for each condition. So one participant here, participant 1, experiences all possible conditions. Okay. So how we'd set that up, like Andy has done here, we have a drink factor with levels of beer, wine and water. We have an imagery factor with positive, neutral and negative imagery. Okay. What was the dependent, the participant, and then the dependent variable is their attitude, whatever that is. Okay. So we transfer all these. You've got to make sure, see on the right here, this is a little tip. Make sure, because it tells you which condition, like which combination this should be. So beer positive, beer neutral, beer negative. So if I just copied these into here, this would be wrong because I had the wrong combination. So this should be, go through each of them, beer positive, then I need beer neutral, then beer negative, wine positive, wine neutral, wine negative, water positive, water neutral, water negative. Okay. When I put those in, it should give me our output here, which is a repeated measures ANOVA. Right, descriptive. Let me just get rid of this as well, just so I can show you like the whole way through. Right, so again, with ANOVA, we could also look at the descriptive statistics for each variable as well, because the assumption of normality is important, right? That we have normal distribution. So to do that, come to descriptives here and put all of our conditions across. Boop. And what we're interested in is the Shapiro-Wilk test here. This tests for the violation. So if it's significant, that means it's bad. And as you can see here, we have one condition violated, and that's it. Just this one condition, be a negative. Now, again, we're not asking you to do anything more than that at this stage, but it's just worth knowing, and I would just report that, just a little note that the be a negative condition showed a deviation from normality, but the rest didn't. Okay, so that's all we need for that. What else do we need? Data's normally distributed. Then we'll talk about homogeneity of variance in a second. We could also look at box plots as well if you wanted to present that. Again, one thing to get across to you all is there's no kind of standard template for every single study that you do. So every single design, the way you've written up your work, it will differ. Right, and I tell the markers this, that there's no one way to write up the report. What you just need to make sure is you get in that key information. This is key information because you need to know that the data is normally distributed for each condition. Yeah. But whether you include box plots or not is also up to you. So to do that, come to customizable plots, click on box plot here, and then you can put these in the appendix. I wouldn't put these in the results, but you get a box plot for each condition. Box plots are important because they tell you, as they do here, click on label outliers, it tells you whether any of the data is an outlier or not. Now, again, we had a question right at the start of the stream about what should we do with outliers. If you listen to what your pre-registration form and you've defined that you'll get rid of outliers, you should get rid of them and then run your statistical test. Yeah? But again, there is that other train of thought or other school of thought that's like, actually outliers shouldn't matter if your data has been sampled strongly enough. Okay? There's obviously a big difference between getting rid of one outlier and getting rid of 20. I'd be very worried if getting rid of one outlier completely changed your analysis. That would suggest there's some issue. Okay? So outliers, normal distribution. The final assumption that we want you to talk about is, come back up here, is for within subjects design is, if you come to assumption checks, is sphericity, right? Now, that'll give you this table here, Morchley's test of sphericity. What we're looking for is to see whether any of those, so there's main effect of drink, main effect of imagery and the interaction between the two, if any of these have been violated or not. As you can see, 2 of them have. Okay, that means that they have been, the assumption of homogeneity of variance for that within subjects factor has been violated, and this is where you need to do something about it. Okay. Let me just put this here. 1 second. What do we need to record from here? I'm just see if there's any questions. Sorry, just to go back very quickly. What should we do if our regression model is not significant? Stop there, Elsie. Don't need to report anything else past R squared. You could put the coefficients table in to kind of prove there's no effect, but you stop there. This is 2A and over KR, okay? Sphericity KR is only for within subjects, yeah. So it's been violated for these 2. So there is actually a very simple thing that we need to do to correct. And what we need to make sure is when we look at our sphericity tests section here, we need to make sure this thing called greenhouse Geyser is correct, is ticked. This is the correction for a sphericity violation. Now, when we come up to our ANOVA table here, we'll see that we now have this line that says greenhouse Geyser. And all we need to do is, and I'll just show you with the note function here, is when we report our main effect, which ones were violated? Drink, right? Is what we would do, I'll show you without the violation. So for the drink main effect, right? I'm just writing this here. The F statement would be F, again, imagine that I haven't checked the assumptions, I'm just like kind of just doing it without looking. It would be F, the degrees of the first degrees of freedom, which would be 2, comma, the residuals degrees of freedom, which is 76, equals 5.106, which is the actual F number here. Then P is equal to 0.011. What was it? 0.011. Okay. We could also include partial eta squared, which you get from, if you come here, you can put estimate of effect size, partial n squared. That just shows you how strong the effect is. It's like a number between 0 and 1. Closer to 1, the stronger the effect. And that is partial eta squared is equal to 0.212 or 21 if you round it up. Okay, now that would be without a sphericity violation, but we have a sphericity violation. So all you do is, instead of reading from the non row, which means no correction, you read from the greenhouse Geyser row. Okay, so now that drink main effect, let me just put this here, drink main effect with GG, greenhouse Geyser correction, will be, we just read, so instead of 2, it's 1.154. Instead of 76, it is 60.678. The F value is not changed, 0.5106. The P value has changed, 0.030. Sorry, and then the partial eta squared has also not changed to 0.21. That is the greenhouse Geyser correction. Yeah? So again, if sphericity is violated for that main effect or interaction, you read from the greenhouse Geyser row. If it is not significant, like the drink and imagery interaction, that's not significant, you just read from the non row. Yeah? So, Grack. So, Levine's test is for a between. It's the equivalent of sphericity for a between subjects factor. Yeah? But there is no greenhouse Geyser correction for a between subjects design. Okay? So, if it is, Levine's is violated, again, we haven't taught you non-parametric tests. We haven't taught you Bayesian tests. It's just important that you note that that assumption has been violated, but you carry on. Okay? So we have so what does our data tell us with our main effect? So we have main effect of drink is significant. Our main effect of imagery is also significant. Our interaction between drink and imagery is also significant. So let's have a look what that actually looks like. So let's go to descriptive plots. Let's put drink on the x-axis and imagery on the y-axis. Click on error bars and make sure you have normalized error bars. And what that should do is give us our data, which looks a little bit like this. Let me just make it a bit bigger so it's easier to read. Right, so here's our data. So what the main effect of imagery is saying, because that was significant, is there's a difference in general. When you think of main effects, just say this to yourself. in general, there's an effect of imagery. So in general, if you look, the positive scores, the white circles, they're in general higher than the black circles and the white squares. Yeah? Significantly so. For the drink main effect, in general, the beer scores are kind of around, on average, around 10. The wine scores have been dragged down by this data point here for negative wine. So they're a little bit lower, and water's a little bit lower as well. Now I don't think that's as strong as of an effect. And if we look at the effect size, it's only a 20% effect, 0.2. Whereas the imagery main effect, which is an 86% effect, which is very clear. The white circles are at the top, the black squares circles are in the middle, the white squares are at the bottom. Does that make sense? I know I'm going quick-ish, but this will be recorded, hopefully. That's what those main effects means. The interaction is also significant. So what does that mean? That means that if we have a look here, for beer, there's kind of a difference between positive, negative, and neutral, but they're a little bit close to each other. But when we look at wine, there's a big difference, especially for this negative wine drink. They go from kind of being the same-ish sort of value to being different, and the same again for water, which is why the interaction is significant, I think. That you have a muddled effect here for beer, for wine, for positive, negative, and neutral, but then you get a very clear effect between these three imagery types for wine and water. So it looks like the effect of one variable depends on the level of another variable. Imogen, for regression, sorry, let me just clarify something for Imogen. With the regression, I'm okay you just reporting that the p-value is significant here. Okay? You could put the F statement, which would be F3199 equals 129.498, p equals less than 0.001. But equally, you'll see in papers that they just say, hey, R squared was this, and the model overall was significant. P is less than 0.001. If that's okay. Right, back to this. So we've done the assumptions, we've done the main effects, we know there's an interaction. Now, what I'm hoping you're saying to yourself is that you know that a main effect just tells us there's an effect. We just don't know where the effect is. This is where it's like the regression, right? The regression, if it's significant, it says, hey, some of those coefficients are significant, but I don't know which ones they are. Yeah? With ANOVA, it's the same thing. It says, hey, in this main effect, some of those conditions are different to each other. I just don't know what they are. Okay? So what we need to do is post hoc tests for each of our variables. So if we come down to post hoc tests here, because they were all significant, you would drag all of these over to here. Now, you only need to interpret the post hoc tests if that main effect or interaction was significant. If, say, for example, the interaction was significant, you would leave that over here and you don't need to talk any more about it. Like Imogen or someone else just said, if the model's not overall significant, what do you do after? Nothing. Same with Anne over here. If that main effect is not significant, that's the end of the story. But if the interaction is significant, you carry on with analysing the interaction. So we know all these things are significant. So by default, I always use the Bonferroni correction, which you might remember from the slides. This is our family-wise error correction. And we should have our, oh my gosh, our post hoc tests here. Now, main effects, as I said earlier, are general effects. It just says, in general, is there a difference between beer and wine, beer and water, and the wine and water conditions? Those three conditions. And the t-test and the p-value here for Bonferroni tells us which is significant. And what it's telling us is there's the only difference that's statistically significant for this main effect is between wine and water. Okay? And this is what you'd report, each of these comparisons. You'd say there was no statistical significant. You'd report the main effect and say, again, have a look at my examples. There was no statistically significant difference between the beer and wine conditions, P equals 0.003, as well as the beer and water conditions, P equals 0.06666. However, there was a statistically significant difference between the wine and water conditions, P equals 0.001. Yeah? Let's move on. Our other main effect was significance. Let's move on to that one. This is the imagery main effect. What were they all different? Now, if you remember, I think they looked like very clear differences between the positive conditions. Let's roll up here. The neutral conditions and the negative condition. It looks like negative on average is quite low, neutral's in the middle, and positive is at the top. Yeah? I hope you can see that. So I would suggest that all of the differences between positive and neutral, are they different together? Yes, they are. P is less than 0.001. Was positive different to negative? Yes, it was. The Bonferroni correction is for the P value is 0.001. Was there a difference between neutral and negative in general? Yes. The P value is less than 0.001. Okay? So what that main effect is telling us in general, right? Again, when we think about main effects, think about in general. In general, there's a difference between the positive and negative condition, the positive and neutral, and the neutral and negative conditions in general. Now, this is a good example of a study where, even though we know these things from those two main effects, these in general findings, what should really guide your interpretation is the interaction, if that is significant. If it is significant. Yeah? And it is. So, this is an example of something I would put in your results section as a table. This is an interaction means, instead of just doing the general difference between taking the average of all the positive, all the neutral and all the negative conditions, the interaction says each individual data point here, so the water negative condition, is that different to the water neutral condition? Is the water negative condition down here different to the water positive condition? And that's why you've got this really big table here, because it's looking at every single condition to see whether it's different from every other condition. So all permutations. You need to put this in as a table in your report. Okay? There's no way you're going to write, it'd probably take up most of your word count if you put all of that in. If you have a post-hoc test table, especially as big as this, put that in as a table, okay? In your results section. Now, what you can see here is that the p-value Bonferroni corrected here is telling you all of the comparisons which are statistically significant from each other. What's interesting probably is because as you can see, all of these are pretty much different to each other. It's more the ones that are not different to each other which might inform your interpretation of the data. Okay? Okay, is there anything else I need to put for this ANOVA? So we've done assumptions, we've done descriptives, we've done main effects, we've done interactions. I think that's it. Unless there's any other questions on ANOVA. So while you're thinking of any more questions, hopefully this has been useful for you, by the way. Please let me know in the chat if it isn't useful. Let's do GeoGuessr, because just to break things up for a couple of minutes. Okay. GeoGuessr, we need to figure out where we are in the world. Can't look at a map. We just need to figure this out. I can either be wildly accurate or wildly inaccurate on this. So let's have a go, shall we? Right. Where are we? Got 2 minutes. Cambodia? Where in Cambodia? Are we thinking Cambodia, everyone? I think so. I'm not going to look at the chat. Let's just see if I can identify where. Right, dead end. Right, I'm going to go. Cambodia. Now this looks quite dry climate, so I'm going to go for somewhere down here. Okay? I mean, that's fairly close, isn't it? So, right, let's do the next one while you're thinking of questions. Okay. My instant impression is somewhere in Eastern Europe, but let's have a look. Can't see anything. Crab? Or like Greek? Oh, hang on, there's a sign here. Okay, that's not. Oh, maybe. Was that the South Korean flag that I just saw? Hang on a second. This is South Korea, I think. Let's have a look. My initial guess of Eastern Europe was wildly inaccurate. Yeah, look at the right. Right, I'm going for somewhere. So it looks quite mountainous. So I'm going to say somewhere perhaps. It was on the coast, wasn't it? Let's go for. I'm going to go for here. Well, I'm happy with that. Right, last one. Well, then I'll have a look at your questions. Right. These have been quite like, this looks again like Southeast Asia to me. Let's have a look. I think this is like Thailand or something. Yeah, the tuk-tuks. Yeah, I think this is Thailand. Interesting haircuts. So I can't read the. Trying to look for like flags or something. Sru Moi Sheng SLC Dental Clinic. Where do we think this is? I think Vietnam or Thailand. That's a nice house. I'm going to go Vietnam or Indonesia. Right, I've got 40 seconds. Right, it won't let me go any further. Right, where do we think? Oh, Malaysia. I feel like it feels quite. I wonder if Bangkok was my. You know what? I'm going to stick with. It could be Burma. But I'm going to go somewhere in. I'm going to go somewhere like here. Cambodia again? Huh. See, it was close to Vietnam though. Ho Chi Minh City. That's not too bad. I did quite well there, so I'm quite chuffed. Right, back to stats. First thought was Thailand, yeah. Right, let's catch up. Wow, this is good because it allows you to type questions while I'm messing about. So, right, where do we get to? How different would between... The only difference, KR, is the Levine's test. That's it. So you got sphericity as the assumption for a repeated measures factor. Levene's for a between subjects factor. If you have a mixed ANOVA, you have a Levene's test and the sphericity as well. My studies are 2x2 design, 2 categorical measurement, extroversion and sex, biological sex, male and female, dependent variable, social media addictions to score. Am I right in saying this is a regular and yes, that's of independent samples or between subjects and over, Candice. Yeah. So there's no repeated measures. So there's a lot of jargon, right? So independent samples between subjects is one type. Those words are synonymous. So that's one type of ANOVA. Repeated measures, paired samples within subjects is another type of ANOVA. Yeah? The median used to split number of hours of video games into groups to make it high and low hours. I'd do whatever you could, KR, to make an equal. It should be an equal split. But that's something. If the median split is 2 and the highest is 24, is it any more fine? Is it like 1.5 or 1.3, or is it like in integers? So everyone's like, has literally everyone put 1? Well, saying that, some people must have put like, if it was split, if it's the median, there should be equal data points. That could be one thing that you talk about in your discussion in terms of a limitation. So don't be upset or anything. Just treat it as like, be honest about it. Do the ANOVA and analyse it in the way that you were going to do. But when it comes to the limitations, you really I'd talk specifically about there not being enough variance between the low and the high group, which might have led to spurious results or not what you thought you were going to get. Yeah. Oh my god, it's 9 o'clock. Time flies when you're having fun with statistics. If you think I should do this more often, like as a kind of a what's the word? Just to keep your mind in track with statistics. I don't just have to talk about, if it's next semester or in third year, for example, when you're doing your third year projects. I'm sure Abby, if she's still here laughing at this, Abby was my project student. That would be useful in third year because you don't have statistics as a module in third year, right? Not randomly split it. I'd do it median split still, KR. But if you want me to do this in third year or in next semester and stuff, if you let me know, I'll do it. Like I really enjoy doing stuff like this, like the whole tech and stuff. And if it's an hour out of my time in the evening, but it helps you all kind of with your studies and stuff, then it's really not an issue. I was going to do gaming as well. I was going to do prop hunt, but my game capture card was like playing up with the audio, so I need to fix that for next time. I was going to play prop hunt on Call of Duty, but to be fair, the amount of talk I can't really play PlayStation and go through JASP output. Between subjects, two-way ANOVA. Yes, if that's the median split, yeah. But again, KR, that's what you talk about in your limitations, right? Oh my gosh, Abby's still here. Hi, Abby. But that's what you talk about, because you talk about the fact that those groups are not different enough. Yeah. I imagine you didn't find an effect. If you didn't, then that's probably why. But that's, again, demonstrating your understanding in the discussions and in the limitation. That's something you'd have to mention. Yeah. I honestly think, Candice, that for statistics, I think it works for statistics for that reason, because it's like a lab-based thing. Do you know, like when I'm getting JASP up like for example, like this, and I'm going through stuff and I'm pointing stuff, I don't need to be in a room doing that with you. Do you know what I mean? Like, I don't need to be there. You can be at your computer with your JASP, and I can go through this stuff with you. So I think it actually really works. For modules that are more kind of, having group work and stuff, that's where you can't do it in so much. It's a bit more difficult. It's not that you can't do it, it's a bit more difficult. But things to the statistics, I think it really works. I don't mind doing these as drop-ins. Yeah, it is a bit different to the usual labs. Yeah, so I'll try and keep these ticking over then into next year. It might be just a case of, like I said in the first couple of weeks with statistics, don't treat it as like it's a maths thing that you just have to do. Even if you're into qualitative work, you need to be able to understand empirical papers that are quantitative and be able to like critique them, but also take away, I'm not saying you have to be a statistical expert, but at least you understand something around the reasons why they're doing that type of study. So that I talked very early on around like multiple, when I want you to go away thinking, when you hear multiple regression, you're thinking relationships between variables, predictions and stuff. When you see a study that's got an ANOVA, you go away thinking, oh, okay, they're looking for these differences between conditions and stuff. That's why I think if we can keep it ticking over, when it comes to your dissertation and your studies beyond and in other modules, which require you to read papers and understand research methods and stuff, that you keep that kind of knowledge sort of ticking over. What section do I talk about the limitations? Yeah, in the discussion section. Just one because of the word limit, I'd say one paragraph. Plus, just to clarify, is there no significance in the main effect of banana? Yes. Yes, Candice. So it's a double-edged sword, right? Because you'll have a smaller results section because you don't have to report the post hoc tests. However, you probably have to put a little bit more thought then into the discussion section as to why it didn't work, which is still interesting, right? Because you've had this study design, so why did it not work? Exactly, Damone. Yeah. Every study tells you everything. Precisely. Yeah? So don't think it failed or it didn't work. It's not. It's like those conditions that you've come up with that at that point in time, with those scales, that those metrics that you use, whatever, didn't produce the result that you were expecting. Why? It could be that they didn't produce the result you were expecting. And that's how the world really truly is. What does that mean for theory and current papers and work on the topics, right? It's Friday night and I'm on JASP. What am I doing? Yeah, but this is really, to be fair, this is really good. I think this time works a bit better because, people have dinner around. I've got my little ones, obviously. I've been to football training with my my eldest boy this evening with the other two as well. So I couldn't have come on any earlier. Yeah, exactly. Yeah, exactly. KR. Don't trash your study. If there is a point, like we talked about the median split. That is a legitimate, probably methodological concern. But I'm just talking in general. Don't trash your study. Be bullshit and think, well, okay, if I didn't find the effect, is a theory wrong? I'm not wrong, but does it need more work to clarify the effect and things like this? Yeah? I'm going to see if I'm going to go on Warzone after this. Yeah, we can do. Right. Any more questions before I can go and escape for a bit? So thank you all so much for dropping in today. There should be a recording on my page. I'll post that link to that recording to the live as soon as it's been processed or whatever, so you can have that to look at. But yeah, like your dissertation, Abby. Yeah. Yeah. So hopefully that was useful for you all. I'm going to go and have a cup of tea now because it's been a long day. As I said, I've been to football training as well as been teaching this morning. So thank you all so much. It's been a pleasure to teach your year group this year, and I hope we can do more stuff like this in the future. If you think if you think it was useful, please let myself or the Director of Education or Lucy as undergraduate director know, because not just for me doing this, but we could probably get other people to try and do it. I could see if I could figure that out, or do more stat stuff like drop-ins throughout the year. That it's not just when that 12 weeks of that module's on. I think just keeping ticking over in your head is I think you'll find that quite useful. So I am going to disappear, and I'll see you all soon. Have a nice festive period or whatever it's called, and I'll catch you in the new year. So thank you so much, and goodbye. Right, how on earth do I stop this? Right. Open Studio. Right. Just turn this off. So again, thank you so much. Yeah. Good. I'm glad to hear that. See you all soon.